In this video, we're going to explore the confidence intervals for the mean of large samples. A couple different definitions to help us out. The point estimate is a single value estimate for a parameter. For instance, we've used x bar as a point estimate for the mean, whereas an interval estimate is looking at an interval to calculate the population parameter. Our confidence level is going to be a probability that that interval includes the actual parameter. And our margin of error is going to be the greatest possible distance between a point estimate and the actual value of the parameter. And lastly, critical values. Those are the values that are going to separate those probable sample statistics from those that are improbable. Now, when we calculate our critical values, we're trying to find the corresponding z-scores that would match with the values. We're going to be given our confidence level, which represents the probability that we are looking at, and we're looking really to find what's our negative z and our positive z. And we've done this before. If we know inside, we know that if we take the complement, 1 minus our critical or our confidence level, that'll tell us how much area is left outside, and then because there's two tails, we divide by 2. Now we can find the negative, or the z-score that's the negative version, by using the norm.inv and everything to the left. And once we have that, the positive is the exact same number except positive. And you could always check it if you wanted to. Here are 3 critical values that are going to be to your benefit to know, because we will use them regularly. So say we want to find the critical values that correspond with a level of our confidence level of 75%. So what this means is inside is 75%, which means outside then has to be 25%. And since I have 2 tails, I can take the 25 and divide by 2 and get to 12.5% on each tail. Now, when I use my norm.inv to find my z values, we got to remember that norm.inv looks at everything to the left. So the easier one is to find the negative, and I'd find that this z-score would be a negative 1.15. And if this one's negative 1.15, the positive has to be positive 1.15. Now, I could also calculate the positive one if I wanted to by adding the 12.5% to the 75% and plugging that in to the norm.inv formula. And it would give me the same answer. Next part we're going to need is the margin of error. Now, we do have some requirements. Either we have to know the population standard deviation, or we have to have a sample that's at least 30. Because what happens is we need to take our standard deviation and divide it by the square root of the sample size. So that should sound familiar because that's the sampling distribution, standard deviation of the sampling means. Now when we take that, we're going to multiply it by the positive critical value that corresponds with that problem. So we always use the positive. So let's look at this problem down here. We're going to find the margin of error for a 95% confidence level when our standard deviation is 9 and our sample size is 25. So when we see this symbol, we recognize that's the population standard deviation. So sample size is not critical to make sure that we could do this problem. So we always have to pay attention, is it population or sample standard deviation we have. So we know our confidence level, 0.95. If you look back at those critical values we should know, this is one of them, 1.96. And we can start to plug in the pieces we have. Here's our critical value, here's our standard deviation, and here's our sample size. We simplify, and we get to about a margin of error of 3.528. Now, if we want to calculate the confidence interval, what we do is we take our point estimate, which in this case is the sample mean, and we're going to add and subtract the margin of error. And what this tells us is within that interval should fall the actual population mean, depending on whatever our confidence level was. So say that Coke wants to estimate the mean number of cans produced each day at a plant. They do a random sample of 49 cans, and the mean number of cans produced was 3,240. And they know from prior studies that the population standard deviation is 148, and we want to do a 99% confidence interval for the population mean. So we know our point estimate is 3,240. Because they want 99% confidence level, we know that, as that's one of the values that we should memorize. And we can plug in all the parts. Here's our z-score, always the positive version, our standard deviation from the population, and our sample size. And it tells our margin of error is about 54.44. So what we do to find that confidence level, we take our sample mean, add and subtract the margin of error. And this gets me down to these two values. So what I could say, and we do want to write these as sentences, we are 99% confident that the population mean number of cans produced at the plant is between 3,186 and 3,294. And the reason, if you look, I can't go down to 85 because I've got the 5, 6, so I have to go up to the next whole number because I'm dealing with cans. And this one I have to go down, not because it's 44, but because I can't go to the next can. That would be outside of my parameter. So I would go down to the can that comes before that. And the last thing you may need to do is actually figure out what's the minimum sample size I would need to estimate my population mean. So to do this, I would have to be given my confidence level, my margin of error. And if I don't know my population standard deviation, I can use my sample standard deviation if a preliminary sample of 30 or more has been provided. So, let's look at an example. Say that I want to find the minimum sample size needed for 90% confidence level. I'm given a population standard deviation and margin of error of 2.4. Now, the z-score corresponding with 90% is 1.645. My margin of error and my standard deviation are given, so I can plug in each of the parts and simplify to find my sample size. So it's just one step after another, multiply and divide. Now I'm going to square, and that comes out to about 39. So what this means is I would need a minimum sample size of about 39 people to do my study.